Here we are in Concorde F, BVFF, Foxtrot, Bravo, Victor, Foxtrot, Foxtrot, number 215. The most recently finished Concorde, here to remind us of the greatest industrial and human venture of this century. The high point in the creation of this aircraft was the delivery of its airworthiness certificate. We have it here, and Mr. Turka will now tell us about the adventure it was to obtain this airworthiness certificate.
This little piece of paper is what we all work for when we test fly our aircraft, as it certifies that our aircraft is safe to carry passengers. We had tested the speeds and the altitudes at which we would fly Concorde before 1958 with the Griffon, but experimentally only. Our aim was to extrapolate the results of the tests to civilian transport aircraft, and we took years to do it. But the result was the crowning of our dreams, the creation of a supersonic airliner.
So much terrain has been covered by civil aviation in 25 years. Concorde flies alongside the most recent aircraft and shows not the slightest wrinkle when compared with the latest off the production line, the Boeing 747-400, which has very rapidly outclassed the Douglas DC-10. Large aircraft with a capacity of more than 300 passengers built on the other side of the Atlantic. In many ways, the Concorde still has the technological edge over the European long-distance transports that have drawn on the experience gained from Concorde's own breakthroughs. Europe's creative genius was born with Concorde and continues in the Airbus family. It was 20 years before Concorde that the fundamental facts of life of the airliner industry changed. A new era, heralded by the application of jet power to transport with the de Havilland Comet, able to fly at 750 kilometers per hour. This fine aircraft, with its rounded lines, was powered by 4 turbojets designed by the British engineer Frank Whittle. It was the yoke Peter in the livery of the British Overseas Airways Corporation, or BOAC, that opened the way to fast and comfortable air transport on the 2nd of May 1952. Unfortunately, its initial flights were marked by a series of disasters. Its structural weakness was to serve as a profound lesson in the construction of the Comet 4, completely reworked but unsuccessfully pitted against the Boeing 707.
We won't burden you with statistics about the size of this airplane, except to tell you that its wing spread is greater than the length of the Wright brothers' first flight at Kitty Hawk.
The Boeing 707 is a symbol in America. With its wingspan of 44 meters, the 707 was to open the jet era in the United States. This 4-engine jet, carrying 189 passengers at 900 kilometers per hour, has been sold to every airline company in the world. Its entry into service in 1958 shrunk the world to half its size. A year later, Douglas, which for so many years had been master of the skies with its legendary airplanes, continued the family that started with the DC-3 and the DC-7 with the DC-8, 4-engined long-range aircraft. The Caravelle was an innovation. With its 2 engines located at the rear of the fuselage, it allowed the wings to be designed clean for more subtle piloting and safer landing. Like Christopher Columbus's Caravelle Santa Maria, the French-built aircraft was the first to land in America, with United Airlines. Its comfort would be appreciated by the passengers of no less than 35 different airlines. You took part in the design and in the certification of the automatic landing system, the all-weather landing gear of the Caravelle. You were already at Sud Aviation, and you certainly must have taken part in the initial design phase of the SST.
Yes, the Caravelle had been perfected already under my predecessor, Nadeau, and the first task we undertook was the improvement of the Caravelle's automatic landing system, together with my friend Max Fischl. But at the same time, I was employed, and this was even in my contract, to start flight testing supersonic aircraft. The engineers at Sud Aviation and some British engineers at Bristol had produced some preliminary studies. From that moment onwards, the flight testing department, and in particular yours truly, were required to advise the research office on all aspects relating to the building of such aircraft. From the cockpit to the flight controls to the control surfaces and piloting techniques.
What has the speed of sound to do with high-speed flying? To find out, let's consider first a single point, sending out small pressure waves continuously. Each wave travels outwards at the speed of sound. Now suppose the point itself is moving.
If the source of sound is an aircraft and the sound waves have the time to move away from it faster than the aircraft moves, then the flight of the aircraft is subsonic. When the source of sound moves at the speed of sound, the pressure waves can't move away from it and accumulate in a line perpendicular to the direction of movement of the source of sound. The flight is said to be transonic. If the aeroplane moves faster than the speed of sound, the pressure waves move backwards and form a three-dimensional cone, and the flight is said to be supersonic. In fast aircraft, the instrument that indicates the relationship between the speed of the aircraft and the speed of sound is the Mach meter. Initially, the pilots of very fast aircraft knew they were breaking the sound barrier only when the aircraft was rocked violently by the shock waves. Whenever an aircraft accelerates to reach supersonic flight speed, the shock waves that form above and below the wings move backwards. The aerodynamic effect of the shock waves alters the thin layer of air that covers the wing, increases wind resistance, and interferes with the control surfaces.
It may cause serious control troubles. Shock waves can even be seen with the naked eye in certain atmospheric conditions. Watch them streaming back from the nose of this missile. There.
The heavy British V bombers were an example of how the Europeans tried to improve subsonic flight characteristics. The Vickers Valiant, with its semi-high wing and its varied sweep of the leading edge of the wing. The Handley Page Victor, with its varied wing extremities or crescent wing. Designers would then create thinner wings swept further back to ease the blowing away of shock waves during transonic flight. And eventually, this would become the delta wing of the Avro Vulcan, tested on the Avro 707.
All four engines of each aircraft are started simultaneously, and well within 2 minutes of the order, all are airborne.
The bomber is in many ways a precursor of the Concorde, with its elegant rounded delta wing and its 4 jet engines, which were an initial version of the Bristol Olympus. Britain goes supersonic on the 11th of August 1954, when the test pilot B. Beaumont takes the English electric P-1, later to be known as the Lightning, through the sound barrier. Then, in 1956, in a single test flight, the Ferry Delta II beats the speed record, reaching 1,821 kilometers per hour, a jump of 480 kilometers per hour, thanks to its pure delta wing swept to 60 degrees. Dassault would adopt the same wing for its Mirage 3. Another first for the Ferry Delta II is the nose lowered for better visibility on landing.
Delta II, a world speed record holder at 1,132 miles an hour.
We can observe airflow using the strioscope. It allows us to see the airflow through the wind tunnel. Once airspeed has reached Mach 1.4, we see the shock waves around the model.
In France, Lucien Cervanti, later to be described as the key designer of Concorde, put forward the idea of a revolutionary prototype with a top speed of Mach 2, the Trident. This would be built by the SN Cazaux. You flew a supersonic aircraft for the first time in 1954. The Gerfaut marked the beginning of your career in supersonic and delta-winged aircraft.
No, it wasn't my first experience in a delta-winged aircraft, because as we knew very little of the behavior of delta wings when we began working on the project, the Air Force had built a small delta-winged glider. I flew first in the glider. It wasn't much of a glider either, as its speed of descent was at its slowest, 8 meters per second, but it gave us a feel for delta wings. Then we wanted to see how a powered aircraft with a delta wing behaved. And the British had developed different types of wing and were ahead in the development of the delta wing. They had the twin-seater Avro 707, the test aircraft for the Vulcan bomber, which we saw earlier. So I got permission to go to fly it and to gain first-hand experience in flying a delta-winged aircraft. This gave us enough confidence to start testing the Gerfaut, although the wing shapes were different. The British had chosen a delta wing design with a sweep of 45 degrees and rather thick, as the aircraft was to be subsonic, as the Vulcan was to be. While the French had chosen a sweep of 60 degrees, or a simple equilateral triangle, and thin for supersonic flight. However, despite being different designs, the PX control surfaces were similar, and this is important in delta-winged aircraft. We flew the Gerfaut for the first time on the 15th of January 1954, and were the first in Europe to reach Mach 1 in level flight on the 4th of August, before going on holiday.
The idea of supersonic aircraft spread through Europe. The designer of this model, the Swedish Saab 210, opened the way to one of the finest bisonic aircraft of the 50s, the Saab J35 Draken. With its double delta wing and external sweep of 57 degrees and internal sweep of 80 degrees, it looks like a paper dart. Meanwhile, the French had perfected their delta wing technology. Cooperating with Ferry, Dassault created a plane with a 60-degree sweep delta wing. The area rule was applied to the fuselage of the Mirage 3A, so as to ease acceleration through the sound barrier and give it brilliant performance. It began flying at Mach 2.2 on the 24th of October 1958. Monsieur Turcat, you've been lucky enough to fly one of the most beautiful aircraft ever built, the Griffon, which must have been a special experience for you as it gave you the opportunity to fly at highly supersonic speeds.
I'm not so sure it was a beautiful aircraft. It was a strange aircraft. It had an odd shape, with a fuselage, with its cockpit placed above the enormous tank that is the Griffon, which, however, contained the rather mysterious engine known as the Statojet, which gave us the opportunity in the years 1958 and 1959 to fly very fast indeed, Mach 2, Mach 2.19 if I remember rightly, and altitudes of 6,000 meters, 18,000 feet, and which allowed us to train for supersonic flight in airliners. But when it came to designing the Concorde, we had the brainwave of asking for the loan of one of the Mirage 4 prototypes. A truly great plane, which was the heaviest delta-winged aircraft France had ever built, capable of Mach 2 for 20 minutes. It was an extremely useful experience, and we were able to train at subsonic speeds too. Before flying Concorde, we had to learn how to fly a relatively heavy aircraft, and we had no experience in this from our test aircraft. The heaviest aircraft we'd ever flown had been the Caravelle, which weighed 50 metric tons. And we were going to have to take off in an aircraft weighing 150 metric tons, which would become the 186 tons it is today. And I also gained useful experience with Air France, which allowed me to pilot a Boeing 707 in a simulated approach without slats, which is not normally done with passengers on board because they are rather delicate. I was also lucky to have an excellent trainer, de Beaucourt.
Oh, Jeff de Beaucourt, an incredible personality.
Wonderful. He really pushed me as far as I could go. And when it came to the first flight aboard Concorde, I think that thanks to all this, and because we all had the same experience, the team was super trained. Mirage 3, Mirage 4, Boeing 707, we had no piloting problems at all.
The Durandal, a light delta wing interceptor, supersonic, and whose aesthetics are quite in line with its operational characteristics. In 1956, Pierre Sartre, creator of the Caravelle and later associated in the design of the Concorde, began work on the Durandal, an interceptor whose pure delta wing had softer tips. The Société de Construction Aéronautique du Sud-Est, SNCAES, later to become Sud Aviation after merging with SNCAESO, built two prototypes. Their performance was to confirm the concepts of future supersonic wings, the thin delta wing with a 60-degree sweep. The shock waves created by the nose of the aircraft and forming an angle in proportion to the aircraft's airspeed follow the lines of the wing perfectly in supersonic flight. The Trident II would end its career in 1958 after a series of performances that would earn it the title of the fastest climber in the world. For the record, Jacques Grignard, the Trident II's pilot, and also later to pilot Concorde 001 alongside André Turcat, beat the latter's climb record, won on the Griffon, by 1 minute, reaching 15,000 meters in 2 minutes and 37 seconds. Roger Carpentier was to bring the world altitude record to France in the Trident II, reaching 24,300 meters starting from the ground. In 1959, the International Civil Aviation Organization asked its 74 members to begin studying supersonic air transport. In response, the French government and Sud Aviation launched the Super Caravelle project on the 21st of April 1960, and the wind tunnel model of this medium-distance airliner was to be one of the stars of the 1961 Bourget show.
And now the handy page 115, the research aircraft with the improbable shape, a supersonic shape for low-speed research.
On the other side of the channel in 1959, the Supersonic Transport Aircraft Committee published the results of its studies, started in 1956, identifying the need for a long-distance supersonic airliner. Practical research will begin with the Handley page 115. Here we see clearly the removable lined wooden wing, which would allow 4 different wing shapes to be tested for behavior at low speeds. This small aircraft, weighing 2.5 tons, with 45 minutes flying time, had a fixed landing gear that limited its speed to 450 kilometers per hour in a dive. The very short career of the Bristol 188, with its welded steel sheeting construction, allowed testing only under kinetic heating conditions at Mach 3. Despite its long and thin fuselage, its unsatisfactory range allowed it to fly at Mach 1.9 for 2 minutes only. Geoffrey de Courcelles, then French ambassador in Britain, and Julian Emery Britain's aviation minister, signed an historical agreement on the 29th of November 1962 for the joint development and construction of Concorde. After long negotiations, the British and French governments decided to launch into one of the greatest aviation adventures of all time.
Every increase in speed
Never has such a detailed cooperation contract been signed by two nations. The agreement involved the equal distribution of costs, work to be done, and profit. It contained no invalidation clause, and 4 companies, whose personnel were to spend 20 years of their lives on the Concorde project, signed the same agreement. Bristol Siddeley and the Société Nationale d'Études et de Construction de Moteurs d'Aviation, SNECMA, were to work together on the Olympus engine. Meantime, in the United States, Lockheed presented its first designs for a supersonic transport. 83 meters long, weighing 227 tons, and able to transport 150 passengers at Mach 2.7 or 3,000 kilometers per hour. Boeing also designed a fast aircraft, built in titanium but using more advanced technologies, with variable geometry wings. Takeoff with 250 passengers on board would be powered by 4 General Electric engines, producing 23 tons of thrust. The engines would be as long as a DC-3. Concorde means research into the chemical reactions within fuels, lubricants, paints, plastics, insulation materials, linings, glass and tires.
Recherche analytique qui dissèque jusque dans ces molécules le métal chauffé au rouge pour en mieux connaître la nature.
This research would lead to better understanding of materials undergoing vibration, the information being transmitted via an enormous spring which acts as a magnifying glass on the surface of the metal. Stretching and shortening cycles are carried out at standard temperatures endlessly, 24 hours a day, for months. Research was done into glues undergoing rapid boiling and slow cooking to find the type that best glues metal to metal. On both sides of the channel, the Concorde project would involve every field of industrial activity. And behind the development of Concorde lies this long and patient work done by 200,000 anonymous workers in 350 companies in France and 250 in the UK. As many drawings were created as aircraft parts, as pieces of metal, used in this aircraft built identically by the British and the French, and which is therefore entirely binational. The BAC 221, a true miniature Concorde, would have a moving nose with different positions for landing and takeoff. This aircraft was the prototype of the Fairey Delta II, very much modified but with the same cockpit. Longer than its predecessor, it was powered by the Rolls-Royce Avon, producing 6 tons of thrust, with afterburner to reach Mach 1.6. Its mission was to verify the behavior of the rounded delta wing, which is difficult to simulate in the wind tunnel, given its sensitivity to air slip. It was equipped with electronically aided controls and auto-stabilizer for these missions. The TSR-2, which would have been an excellent supersonic attack and reconnaissance aircraft, was sacrificed so as to ensure fulfillment of the Concorde contract. Thus, it was the Concorde that would inherit the Olympus Mark 320 engine, Bristol Siddeley designed and Rolls-Royce built. With the launch of the TSR-2 project, the British government had insisted that the two companies work together. The TSR-2, powered by two 14-ton thrust water-injected Olympus engines, could fly at 3,000 kilometers per hour, but budget problems would ground it. The news exploded like a bomb in Paris. Harold Wilson was threatening to abandon the Concorde program too, due to budgeting reasons. After 3 months' uncertainty, the aviation minister announced that the contract would be honoured and Concorde began to take shape. Each technological step forward was verified in the wind tunnel so as to monitor the effect on stability of the turbulence over the wing surface, which would evolve until the final production wing was ready. Its simple ogival shape would later be defined by the Office National d'Études et Recherche Aérospatiale as flamboyant Gothic. These tests show how the lift evolved as angle of attack increased. The wing profile would therefore be modified so as to ease airflow in front of the air intakes and ensure air reached the engines in all flight conditions. The results of all this research would allow designers and engineers to create a Concorde that would satisfy airline companies the most. Coming to terms with this vital element, the air that the wind tunnel supplies constantly. The production line would therefore undergo changes as research proceeded, and every new element would be tested on the whole aircraft in the wind tunnel so as to verify final performance. Suddenly, Concorde becomes man-size. The aircraft, studied by chemists, physicists, designers, and whose every parameter has been calculated by computers and tested in the wind tunnel, begins to take its true shape and size. The yellow parts in this cutaway drawing of the Concorde are built in France. Sud Aviation at Toulouse has 3 sites. Blagnac, where 2 million hours of work were done in design offices before the first Concorde began assembly in October 1965. Saint-Martin-du-Touche, where some of the fuselage and wing built at Marignane and Nantes were put together. And then Saint-Éloi, the first construction unit in Europe equipped with computer-controlled drills. On this thin strip of magnetic tape are written all the instructions for the automatic drills. Every 3-dimensional movement of the drill is dictated silently by this tape player. The main and forward landing gear are built by Hispano-Suiza and Messier. They would be tested to 190,000 times before being certified. A model of the aircraft allows for perfect placing of each part and the laying of internal circuits. The full-scale model shows the location of each piece of equipment, the fuel tanks, the baggage hold, the air conditioning system, and the 240 kilometers of cable that run through this electronically controlled aircraft. The red areas show the parts built in Britain by the British Aircraft Corporation at Weybridge. The same wooden model principle is applied to the cockpit. The visor is lowered and the nose moves to 5 degrees for takeoff and approach. For final approach and landing, the nose is lowered further to 12 degrees so as to compensate for the high angle of attack of the aircraft. In production aircraft, the whole window surface would be in glass. Part of the front fuselage was built to undergo static fatigue tests. Called the éprouvette, this was sunk into a tank at the Établissement Aéronautique at Toulouse and then submitted to heating and cooling, and then to varying pressures so as to verify its resistance to stress, and therefore the operational life of the Concorde. The British Aircraft Corporation factory at Weybridge also built the rear fuselage, the tail cone and the rudder, which weighs 1,200 kilos. These parts were then mounted and tested at Filton, where the horizontal control surfaces were attached to the tailplane using Teflon-lined rotation mechanisms. The Olympus, which powered Concorde, began flying with British prototypes.
Yes, an aircraft is built around an engine, and this is the most time-consuming and difficult part of building an aircraft. Although in theory a prototype aircraft is never built around a prototype engine, sometimes it's inevitable. Then the Olympus engine developed by Rolls-Royce had already powered the TSR-2 fighter, which was unfortunately abandoned later, and then tested on the Vulcan. I also had the opportunity to fly an Olympus-powered Vulcan. But the total number of hours it had flown before it was mounted on the Concorde for the ground tests was about 75. It was still a very young engine, very much a prototype. But later, and once Rolls-Royce teamed up with Snecma, it was to perform extremely well. What I most appreciate is the stability of the engine, thanks to its electronic regulation system. It is an extremely precise engine. When the throttle is set at a given level, the engine stays there, which is more than can be said for other engines that need to be continually adjusted as external conditions change. Managing the engine is very simple. It never caused us any trouble.
The Olympus jet engine was designed to power subsonic aircraft and needed to be adapted to supersonic flight at 2,200 kilometers per hour. The rectangular air intake of each engine was designed to reduce the speed of air entering the intake via a variable geometry duct. The jet exhaust was designed to allow for the best possible functioning of the Olympus engine at supersonic speeds using variable diameter nozzles. When closed, these act as thrust inverters. The whole group, known as the TRA, was built in France by Snecma. The assembly of this immense puzzle, each of whose pieces had been created thousands of miles from each other, began on April 7th, 1966.
There are two assembly lines, but there is no duplication of work done by the pre-assembly plant. This is the Sud Aviation line at Toulouse, where aircraft 001 and all the odd-numbered Concordes will be built. And this is the BAC plant at Filton, where all the even-numbered aircraft will be built. Both assembly lines receive their materials from the same sources.
Assembly of Concorde 001 began on the 7th of April 1966 at Toulouse after more than 3 years of research, tests and construction. On that date, 50 Concordes had already been ordered by 11 airline companies. A fleet of lorries feeds each construction centre on either side of the channel. They line the roads to and from the centres with outsized loads. Some roads are negotiated using articulated trucks to avoid obstacles. The fuselage, the wing and the tailplane weigh 33 tons empty, which goes to show that Concorde was not just another aeroplane. It was the largest aircraft construction project ever undertaken in Europe. An air bridge was organised using RAF Short's Belfasts. The prototype of this 4-engine turboprop had flown for the first time only 2 years earlier on the 5th of January 1964, and it could carry 311 cubic meters of load. Before being replaced by the Guppy, it connected Filton with Toulouse in less than 2 hours. Each part was built by co-workers 1,000 miles away, by colleagues whose language and culture were different. The surreal nature of the task of joining the different parts was highlighted by the measurements being in millimeters at Toulouse and tenths of inches at Filton. Elizabeth II congratulates the employees at BAC, while at the Sud Aviation Works, President Pompidou shows great interest in the assembly hall. The very spectacular rollout of Concorde took place in December 1967. But the work that would lead to the first flight still had to be done.
Yes, but the rollout in December 1967 was perhaps the most emotional moment for me. For the first time, we saw the aircraft in its entirety, without scaffolding, painted, and we could appreciate its true size outside the hangar. And it was at that moment that its beauty, although it was to be further perfected in production aircraft, impressed us all. And I think the same is true for all the different flight crews that were to be responsible for flying this aircraft, which was the fruit of millions of hours of work.
Unexpected competition for Concorde came from the east and was nicknamed Concordski. Tupolev had begun work on an aircraft that could fly 6,500 kilometers at Mach 2.25 with 121 passengers. On December 31, 1968, pilot Edouard Eliane, accompanied by his crew, saluted Andrei Tupolev, who'd come to encourage them in their enterprise, the first flight of the Tu-144 alongside the analog 144, a miniature Concordski. Backed by very strong political pressure, by flying on the last day of 1968, the Russian plane would beat the Concorde to become the first supersonic civilian transport aircraft to take to the air. But the strongest competition would come from the United States. On the 9th of February 1969, 1 month earlier than the Concorde, the largest civilian aircraft ever built was to fly for the first time, the Boeing 747. This 315-ton giant was to turn the economies of air transport upside down. It was nicknamed the Steamer of the Skies and was to cast a shadow over the development of the Concorde. And with 1,000 aircraft built, today the 747 is recognized as one of the industrial successes of all time. Toulouse, March 2nd, 1969. André Turcat and Henri Perrier receive their orders before taking their seats aboard. Michel Rétif, the flight engineer, ends his pre-flight check and prepares the cockpit alongside the pilots. Then the checklist is gone through by the chief test pilot and the co-pilot Jacques Guignard. The crew is now ready for the first flight of the Concorde. It's 15:40 and 11 seconds. André Turcat releases the brakes and the Concorde, with all 4 engines alight, begins its takeoff run. The aircraft keeps its undercarriage down for its first flight. The man who knows Concorde best, Henri Perrier, flight test engineer, checks the flight parameters from his cabin, full of computers and recorders. Watched on television by viewers the world over, the Concorde makes its approach and lands for the first time, followed by a meteor of the test center which monitors its speed. André Turcat and his crew are welcomed by the crowd of invited guests and the employees of Sud Aviation, who've spent 7 years of their lives designing and building this aircraft with incredible enthusiasm.
But that aircraft had fixed geometry air intakes. The air intakes were to direct inlet air towards the engines and reduce its speed from supersonic to subsonic. The intake regulation systems were not yet ready, and we had to fly with fixed inlets, which reduced the scope of our tests.
It's April the 9th, 1969, and Concorde 002 is ready for her maiden flight from BAC's airfield at Filton. As in Concorde 001, no passenger seats, but 12 tons of flight test equipment. Today, the six-man crew was led by Brian Trubshaw, Director and General Manager, Flight Operations, BAC Filton, together with his co-pilot, John Cochrane. Of thousands of people concerned with the production of 002, few have awaited this moment more eagerly than those whose job it is to finally prove the aircraft in the air, the flight test crew.
The door is closed by the runway controller. His gesture seems to be an act of love embodying the passion that the runway technicians have for the aircraft. The same sequence of events has occurred at Toulouse follows, in an identical aircraft, a copy that's been built solely to satisfy national pride in the two countries. With two minor exceptions, Brian Trubshaw has already flown in the 001 alongside André Turca, and the three British test Concordes will be the only ones to carry the name Concorde on the blue background of their rudder.
The great day was interesting, to put it mildly, and very exciting, because we'd had 2 days of frustration with the failure flag on the first pilot's airspeed index popping up every time we did a taxi run up above 80 knots. And after about the third go to fix it, I said to the engineers and the designers, well, if it works this time, we'll go. We're not going to come back and tell you it's working. Unfortunately it was, and off we went.
Concorde 002 is clear takeoff, and good luck, gentlemen.
Fingers crossed. Il roule. Nous croisons les doigts.
Full power and reheat.
At this point, Brian Trubshaw decided to turn a high-speed taxi run into a first flight.
Hey! So obviously the ASI is all right.
Merveilleux. Bon décollage.
Anything that comes from the...
The four afterburners accompany the small jet of smoke created by the prototype's engines. With its undercarriage lowered, Concorde 002 flies toward Fairford, the RAF base where flight tests will take place.
For 002, Fairford technique, roger, understand working control.
02, you're clear to land from this approach.
Well, on an aeroplane where the pilot's eyes are very high off the ground when the main wheels touch, you need to be aware of the height quite accurately, and you use radio altimeters for the last, say, 100 feet or so, and they're called out either by the co-pilot or the flight engineer in the case of the Concorde, and we were denied their accurate information on our first flight because they both failed during the flight from Filton to Fairford. It wasn't too bad. I think we arrived about a quarter of a second early.
After a 22-minute flight, Concorde 002 landed safely at the Royal Air Force Airfield at Fairford in Gloucestershire, the British base for Concorde flight operations. After years of careful study and dedicated attention to detail, here was another thrilling and rewarding climax for the thousands of men and women working in the factories of British Aircraft Corporation and Sud Aviation, in the knowledge that the British-built Concorde flew just 5 weeks after her sister 001, and that 2 Concordes are now flying. Brian Trubshaw said the flight was cool, calm and collected, and that the crew enjoyed it immensely.
This flight is the culmination of 7 years' work, but another 7 will be needed before the aircraft becomes operational.
Farnborough was an appropriate choice, but the huge RAE Structures Laboratory there has a key role in the ground test program. A complete Concorde airframe is being fatigue tested under simulated supersonic flight conditions. The CEAT laboratory at Toulouse is static testing a second airframe, again with simulated kinetic heating effects.
Concorde, opening new horizons in manned flight, will also undergo the toughest static testing. Its wings are bent as far as the most violent gusts of wind will ever push them. The simulation involves the heating of the materials to the highest possible temperatures so that each hour of testing simulates 3 hours of flight. These tests are decisive as they will determine how long each airframe will last over time.
Rigorous ground testing makes for trouble-free flying. On this rig, the Concorde undercarriage has been subjected to thousands of takeoff and landing cycles.
This model of the fuel circuit, which includes 13 fuel tanks, of which 3 have a balancing role, is shaken in every direction so as to simulate all attitudes and in-flight acceleration conditions. The aircraft is inspected after every flight, is re-prepared for flight and brought back to the runway.
Takeoff is scheduled for without auto stabilization, so it'll be.
The pilots are briefed as to the tests involved so that they know which parameters are going to be monitored in each maneuver. Each aircraft carries 12 tons of equipment and the parameters are monitored by the flight engineer. Each new flight pushes the aircraft a step further. The aircraft is put through its paces, its performance recorded. Concorde 002 taxis slowly as even during this phase, tests are being carried out. It passes in front of the Canberra that accompanies it during the test flights. The two Concordes total 120 hours of flight in 6 months. On the 1st of October 1969, Concorde 001 breaks the sound barrier over the Gulf of Gascony.
Vibration tests had opened new vistas in terms of pure speed. Now we had to increase speed, and with the variable geometry air intake systems, during the 1970s we were to make progress. With great prudence, but for different reasons, because we were worried about the possible effects of an engine cutout, or the cutout of two. The Americans had had many a problem in this field. Their bomber B-58 Hustler had crashed several times at Mach 2 and had had accidents due to engine breakdown.
We had to operate the aeroplane to get the maximum range, obviously. And so doing, it meant that you operated the engine as near to what's called the surge line as you dared. And getting the margins correct, which meant tinkering with the intake, was quite a drawn-out performance, and it went on right through the whole development program.
So we went carefully, step by step, and were pleasantly surprised to find that aircraft handling was good up to Mach 2, and that even with 2 engines out on the same side, the pilot still had several seconds, which is a long time, you know, to regain control of the aircraft.
To these men, flying at twice the speed of sound is part of the daily routine. Mach 2, about 1,350 miles an hour, or slightly faster than the muzzle velocity of a .303 rifle bullet. Mach 2 is now routine.
Then we were not only concerned to test fly at high speeds, but also at low speeds, to allow for landings under normal conditions. In other words, landing at higher angles of attack than would ever be used by normal aircraft. These were exciting tests. First, we tested straight landings, then simulating a sudden obstacle in the line of approach, another aircraft crossing our path, for example, simulating avoidance techniques. So we tested increasingly violent maneuvers at different approach speeds and increasingly brutal avoidance maneuvers. And then we decided to push the aircraft to its limits with the most violent maneuver possible, and I saw the angle dial increase. We had a small indicator of angle of attack, and the needle began spinning like a ventilator, and I realized that we would have to react quickly if we were not to put the aircraft at risk. The aircraft responded well. We had gone far beyond the conditions for which the design office had guaranteed the safety of the aircraft. All we had to do was to develop a better safety system, so that today it is impossible for the pilot to go beyond certain danger limits, even if his avoidance measures are violent at approach speeds.
By the beginning of 1971, the test Concordes had been through all their paces with 417 hours of flight, of which more than 100 supersonic during 207 individual flights. They'd been pushed to the limits of the blue skies that they would leave to their successors, modified as a result of the tests they'd undergone. Concorde had learned to fly fast and high. It now needed to fly far. As of 1971, Concorde became an airliner and had to share the skies with other airliners.
Concorde's first intercontinental flight was to Dakar in West Africa. .001 flew back to Le Bourget, 2,500 miles, in under 2.5 hours. The present schedule is about 6.5 hours. Today's air transports and tomorrow's.
Several public figures flew in Concorde during several demonstration flights from the Bourget Air Show, including the chairman of all the airline companies that had showed interest in the aircraft, and all declared how surprisingly comfortable the flight had been.
Then after this flight to Dakar, we thought that the best destination for the aircraft was the Aerospatiale route to South America, to Rio de Janeiro or Sao Paulo. But the prototype didn't have that kind of range and couldn't cross the Atlantic, not even the South Atlantic. So we stopped off in the Cape Verde Islands so as to shorten the South Atlantic crossing, and from there flew to Cayenne. And from Cayenne, we flew what I would call almost a sea route over the virgin Amazon rainforest to Rio de Janeiro and Sao Paulo.
Flight testing went so well that VIP flights became a practical possibility.
President Pompidou took great interest in the aircraft. He was a close friend of the chairman of the company, and I was called several times to the Élysée Palace to tell him how the project was proceeding. And then he decided to fly in it. I went to fetch him in Paris. We did a tour over the Atlantic at Mach 2 and landed at Toulouse. He was a little tense, I would say. He wasn't very confident. And when we landed at Toulouse, there was a great crowd waiting for us, there at the airfield. To leave the aircraft as quickly as possible, he embraced me. And I'll always be thankful to him for that, because I have a photo of the event. I think he embraced me first as a courtesy, to thank me for the flight. Then it was also a political gesture to show that he had confidence in the project. But also, I think, because he was relieved.
On the 28th of July 1972, the first sale of Concorde was made. British Airways bought 5 aircraft and Air France 4, the price per aircraft being $31.2 million, 10 million more than a 747. The Chinese delegation at Le Bourget showed great interest in the 001 prototype, but would take only an option of 3 aircraft. China Airlines thus became one of the 15 airline companies having expressed their intention to buy a total of 70 aircraft.
The supersonic...
No firm orders, however, backed up the charming smiles of their hostesses.
Even to the pretty stewardesses.
Concorde 002, piloted by Brian Trubshaw, overflies Athens in June 1972 at the start of a long promotion flight to the Far East. It would stop off in Iran, India, Indonesia, Japan and Australia.
Well, in fact, both prototypes did a lot of promotional flying much earlier than you would normally expect in a program of this sort. And one of the main reason for that was that there were a lot of oppositions building up to Concorde, and it was necessary to keep the aeroplane in front of the world. And in the course of that, one met all sorts of interesting people. The late Shah of Persia, for instance, as it was called in those days. He flew the aeroplane, actually, because he was a fully trained military pilot. And we went everywhere.
The final destination of this promotional flight was Australia's finest city, Sydney.
.002 has done its share of VIP flights. Australian government representatives go aboard to learn at first hand what Mach 2 is going to mean to intercontinental travel.
Trouble for Concorde would begin with demonstrations in Australia. This would be the first of a series of setbacks that would put the whole project in danger. The United States and the United Kingdom would soon be overtaken by opposition to supersonic flight that would make more noise than the aircraft itself.
No sensible mother would feel happy about leaving her baby in the pram in the garden in the neighbourhood of Heathrow while these Concordes are passing.
Despite the support of the President himself, public funds required to continue the development of a supersonic transport in the USA were denied the Boeing 2707. This was then exploited by the environmentalist movement, which would obtain legislation forbidding supersonic flight over the US.
The SST is charged with doing everything but causing ingrown toenails, and I'll be surprised if the misinformers do not find a way to do that.
The hopes Concorde's builders had cultivated after the meeting between Presidents Nixon and Pompidou was sunk without trace when Pan Am, followed by all the US carriers, terminated their contracts.
I must say that when the Americans abandoned the Boeing 2707, their supersonic project, we were sorry, because we knew that we would be alone, facing all the difficulties we would come up against in the Concorde. If we had had that competition, we would have felt that the problems were the same for all of us. They would have had the same noise problems, the same problems with the bang, with the PX, and that would have helped us.
The Concorde continued making promotional flights to Bahrain, for example. By bitter coincidence, the last hopes of commercial success for Concorde were dashed in that self-same region. On the 22nd of December 1973, the oil producers met at Tehran to double the price of oil. None of the Gulf states would confirm their orders. And yet Concorde had proved during its tests that it could operate from any runway, from any airport, even from Singapore's. The two countries, however, decided to continue production of 16 Concordes plus its prototypes. All aircraft assembled in Britain would carry even numbers, except for the pre-production 01. A new version of the Olympus would be developed with fuel injectors and with a 50% reduction in smoke emissions. All French-assembled aircraft would carry odd numbers, except for the pre-production 02. Use of the guppy would intensify construction, also used by Airbus industry in association with Aero Maritime. Its 6-metre hold easily carried the 2.88-metre fuselage of the Concorde. The Guppy 201 is a conversion of the Boeing B-377 Stratocruiser, powered by 4 Allison 5,000 horsepower turboprops.
Not just treaties and promises, but air links and computer lines.
Assembly lines began receiving materials faster. Colleagues on either side of the channel used the same plans, but in different languages. Flooded runway taxi tests were carried out by Concorde 02, the pre-production aircraft closest to production types. Of course, they were to prove how safe the braking mechanisms were. But first, the engineers had to study the dispersal of water caused by the front and main landing gear. The entry of water into the air intakes caused an engine failure. The response was an automatic reignition system which involved pumping large quantities of fuel. This aircraft, bearing the French colours to port and the British colours to starboard, was to take part in the freezing tests in Alaska. It left Toulouse on the 7th of February 1974 and landed at Fairbanks after 5 hours and 43 minutes flight, with a stopover at Keflavik. It was to prove as stable on snow as on water. Let's hear what André Turca has to say.
Things change below minus 30 degrees. You can't just go around as before. You have to be protected constantly, your nose, your ears, etc. Then there were small problems with the aircraft. But they were minor problems. After having abandoned the aircraft for 36 hours, that was the rule, for 36 hours at minus 45, we returned. The first problem was getting into the aircraft. The door was stuck. Then the second problem, inside the cockpit the temperature was minus 27. But in the end we were going to have to welcome passengers on board, and we couldn't welcome them at minus 27. Second test, heating the cabin. We had to make a last-minute change. We couldn't tow the aircraft, as a plug had been put into the hole where the hook goes, and we couldn't get it out. We had to blow hot air onto it for 2 hours before being able to pull it out. Making the original hole just a bit bigger allowed us to solve the only real problem we had under freezing conditions.
After the endurance flights on the commercial routes Paris-Rio and Paris-Boston that had aroused a great deal of interest, Concorde made a new promotional tour to the Pacific coasts of the Americas. The first stage of the American tour, London to Mexico via Gander, over 9,300 kilometers, was a technical success. Concorde 02 was received by enthusiastic crowds. André Turca took advantage of the tour to test takeoff from a runway at 2,300 meters altitude to verify Concorde's performance. He landed 2 hours and 19 minutes later at San Francisco. The encounter with another legendary aircraft, the DC-3, still serving after more than 35 years. The San Francisco-Anchorage-Los Angeles flight was fast but subsonic. To get round the ban on supersonic flight over American airspace, the route had to be moved over the Pacific. André Turca was welcomed as an ambassador throughout South America. Many public figures were to fly with Concorde in Ecuador and Colombia. On takeoff from Bogota, they appreciated the maneuverability of the aircraft when Jean Pinet turned abruptly to avoid a single-engined aircraft flying in his air lane. The return flight from Lima to Paris via Caracas and Las Palmas was entirely supersonic. On return to Paris, the O2 pre-production aircraft had flown 11,600 kilometers, had accomplished its 200th flight, and had flown a total of 58 hours, of which 50 with no mechanical failure. The certification received on the 10th of October 1975 was the basis of the options that the airline companies would have to exercise. Everything had to be ready for the passengers. Emergency exit slides, furnishings of the cabins, linings of the windows and carpets had to be laid. The version used could host 100 passengers in 2 cabins with a front and rear galley. Cabin layout was sent to the agencies, and on the 15th of October 1975, 3 months before its inauguration flight, Air France announced that the first flights were sold out. The International Air Transport Association fixed the price of the Concorde ticket at 20% higher than the price of first class. It was in 1975 that the first Air France crews began piloting the aircraft during the qualification flights. The crews came to qualify on Concorde.
Yes, we carried out the qualification flight on the Dakar route. We flew to Dakar. The pilots were surprised by the handling of the plane, although they had been in it before, of course. For pilots who had spent years at the controls of heavy aircraft, such as the 707, it wasn't easy to come to terms with an aircraft that handled like a fighter, which reacted to the slightest pressure of the fingers. They all felt the difference, but not all of them managed to come to terms with it. Not completely, anyway.
The training course for the Concorde conversion is probably the most complex course that there is in civil aviation. It goes on for about 6 months. From the time you actually start to the time you're finally finished and are flying passengers, it takes between 5 and 6 months for all our pilots. And it is a very intense course. The ground school course, where you learn all about the switches, the dials, the systems, the limitations, takes about 2 months. And you fly in the simulator. It's a very good simulator. We fly 16, 17 4-hour details on that machine, and then eventually you start to fly the aeroplane, but under the supervision of a training pilot who's been operating Concorde for quite some time. So it's a very difficult course, and it's a very difficult and different aeroplane. The main difference is, of course, the speed, and you have to learn the systems to cope with supersonic flight as well as subsonic flight. Also, at slow speeds, it's got a great deal of drag, and it's speed unstable in that respect. And that also takes some practice at learning the handling characteristics and learning how to cope with it. But once you're used to it and once you become familiar with it, then it's a joy and a delight to fly.
At midday, a hostess announces, not without a touch of emotion in her voice, that the passengers on the Air France flight for Rio are kindly requested to proceed to the gate. The roar of the Olympus engines with their 8.5 metric tons of thrust speed Concorde into a new era. On that Wednesday, the 21st of January 1976, at the same time, the same scene takes place at London Airport for the privileged passengers for Bahrain, who would live the greatest adventure in the history of air transport, flying faster than the sun. Air France used the first passenger flight of Concorde to present its new logo, an eloquent expression of France's technological lead. For both companies, Concorde would become the symbol of excellent service and would contribute to their inimitable image.
Well, we've had the most excellent supersonic lunch, and we couldn't be more comfortable, and it's the most tremendous and very exciting experience.
Based on the same concepts, the Tu-144 was a copy of the Concorde. They were only a few hundred centimeters different in length. But the Tupolev transport was less powerful. Entering service on the 26th of December 1976, it would only transport freight and post, its range being too short and the vibrations created at speeds around Mach 2 being unbearable and accompanied by enormous fuel consumption. Despite the contrary opinion of the engineering community, it was given passenger transport tasks between Moscow and Alma-Ata in 1977. 6 months later, it was retired. Its career had been scarred by various minor incidents and 2 accidents. It must be said, however, in all fairness, that the Soviet Union was the only country to allow Concorde to fly supersonic over its territory. I think there are a lot of Americans like me who are in favor of Concorde. Unfortunately, the US administration did not share Kirk Douglas's opinions. The 6-month delay in obtaining authorization for Concorde to land at Washington Airport was the first sign of a struggle that would last 18 months between the Port Authority of New York and the companies managing Concorde flights. The most profitable route economically was opened at last on the 22nd of November 1977. The fact that flights to the United States are the main route served by Concorde explains the reluctance of Washington to allow it to land in the US. Concorde remains a model of perfect technical regularity even in 1994. Every day for the past 20 years it's shown how efficient it is, used to the best of its capacity. It's shown the way ahead in the realm of electronic flight controls. It's contributed significantly to techniques of fuel distribution, in ensuring flight stability, and both these technologies have been incorporated into the Airbus A310. For the first time it used advanced glass surfaces, now commonly used in modern airliners, and was the first aircraft to use carbon fibers in brake mechanisms, which can stop all its 185 tons traveling at a speed of 400 kilometers per hour. But above all, it's a beautiful bird. Its design is elegance itself. It's the marriage of power and beauty. It's the only flying wing to transport passengers. It's the only aircraft to offer the unbeatable comfort of short flights with refined in-flight service. On the 12th and 13th of October 1992, it broke the round-the-world speed record in 32 hours, 49 minutes and 3 seconds. Together with two of the greatest aerobatic teams in the world, it has excited aviation fanatics with fine displays. In 1989, the 200th anniversary of the French Revolution, celebrations for the 20th anniversary of the first flight of the Concorde were held at Toulouse. The personnel at Sud Aviation remembered with deep emotion the adventure that was the flight certification of Concorde, which on that occasion carried the revolutionary colors. The ceremony was organized in the giant hangar and allowed the youngest members of the team to meet the pioneers. Brian Trubshaw and André Turcat were given standing ovations, as was Henri Perrier and Michel Rétif, who contributed to the training of the Air France crews, and Gilbert Comery and Dr. Bill Strange, the founders of the design offices. They were all saluted by the orchestra of the Capitale de Toulouse, conducted by Michel Plasson. It's going to be tough finding a replacement for Concorde. Despite the presence of several Russian-built prototypes here at Le Bourget, the economic reality is that any future projects will be the result of international cooperation. For the past 4 years, 8 of the world's greatest builders have been studying the development of an aircraft that would cover 10,000 kilometers at Mach 2 with 200 passengers. But on the 7th of April 1994, the fathers of Concorde, Aerospatiale and British Aerospace, associated with Deutsche Aerospace, created PERS, the European Programme for Supersonic Research, financed by all 3 countries. This alliance will give its name to the aircraft that will fly in 2010.
So over the many years of design and development, we tried to create an aircraft where the passengers would feel comfortable, but where the pilot would feel happy too. So, now you must tell us what you think of this aircraft that we delivered to you on the 21st of January 1976.
Well, I started flying it later, but I must say that as far as I'm concerned, it's an aircraft that surprised me. It surprised me by the way it handled and by its quality in general. It's an extremely sensitive aircraft. Its intelligence surprised me. You spoke of the help you tried to give the pilot, and in high-altitude flight, I must say that the automatic pilot is remarkably intelligent. This aircraft can fly at high speed, at high temperatures, it climbs fast, it loses height smoothly.
We did our best.
So on the whole, it surprised me.
Well, I think all of us that have flown Concorde become attached to it. It's a magnificent aeroplane, the most tested aeroplane that there's ever been, and it handles superbly. Once you've been through the course, once you become used to it, you never become overconfident with it, but it's like driving a racing car, it's like riding a stallion. It really is something special. It's very exciting, and I think, well, I've been flying it now for almost 20 years, and it's still a thrill each time I take off, each time I come into land. And it's still something really special when you're sitting up there at 60,000 feet and watching the world go past at Mach 2. It's apart from the rest of the aeroplanes. Concorde is very, very important to British Airways. Along with Air France, of course, we're the only 2 companies to operate the aeroplane, and it sets us apart. It's something special, it's something very, very different. And no matter where you take the Concorde, thousands of people turn out to see it. It has that extra attraction and extra appeal. I think that clearly people make the implied thought that if we can operate and fly Concorde, then we must be a good airline. The other big benefit is that we fly as passengers on our regular flights, regular services. Many of the world's decision makers, the politicians, the businessmen, they fly in Concorde because they need to save the time, they need to use that which Concorde offers, which is to get you across the Atlantic very, very quickly. So it does mean that if we impress those people, that we stand a fair chance of getting some extra business from their companies. But my belief is it will be quite a long time before we actually see a successor to Concorde. And so for the next 5, 10, 15, probably even 20 years, I think the future of supersonic flying still remains Concorde. It's way ahead of any opposition, and it's in service and flying every day.
I think the Concorde is a wonderful example of what you can achieve, sometimes in spite of politicians, if you really mean to. I mean, nobody thought that such a complex project could be made to work the way Concorde has worked. And it did work because nobody was going to allow it to be a failure. I think everybody that was involved on both sides of the channel were tremendously proud to be in it, and consequently they got on with the job. Every now and again somebody interfered at the top, but it happens, and it shows you what you can do. But you have to have determination, you have to see the other person's point of view sometimes, you have to have a level of understanding, but above all, it's the determination that this is what you want. The Concorde has had a big bearing, in my view, on the very successful formation of Airbus industry. And Airbus industry has become, and will always be, a great competitor to the American aircraft industry, which up to the arrival of Airbus industry was dominating really all of the civil world.
I have to say also that it's a very reliable aircraft. It can be temperamental sometimes, but it's extremely safe. I must say that I flew 707s and 747s for many years, and I thought I knew what safety was. In this aircraft, I've always felt totally safe. I felt that the designers had gone to great pains to calculate every single possible parameter and that it must be safe, and it is. So, to conclude, I'd just like to say I'm proud to have served with this aircraft for so many years, and that for me, these have been the finest years, the finest flying hours of my career.
Edouard Chemel, I agree with what you say. But I think it would be right for us to mention all those who worked in the background to build this machine. And there are tens of thousands of people with a total of millions of hours of work without our ever having mentioned them. One tends to talk about those who become famous in some way, but we don't like to blow our own trumpets. So I would just like to conclude by saying that at the base of the whole project there is an essential ingredient found in all of the people who worked on construction, those of us who test flew the plane, and those who've been operating it, and that is passionate enthusiasm.
A quarter of a century separates the completion of the first and second Anglo-French joint projects, Concorde and the Channel Tunnel. The mutual trust and esteem forged between the two nations during the construction of Concorde were consolidated in Europe's biggest ever civil engineering project, the joining together of the two countries. The tunnel has become the physical symbol of the ties between the two nations.